Good morning, class. Did everybody have a nice weekend?
Yeah.
Okay. Is everybody ready to learn how to balance chemical equations?
Yeah.
You gotta get ready. So before we talk about balancing chemical equations, we're going to talk about plants. I was watering one of my house plants last night, and I started to think about what an amazing creature it was. It actually makes its own food. It breathes in carbon dioxide, and it takes up water from the roots, and it rearranges these and combines them to make sugar, a sugar called glucose. And it does this using energy from the sun. Now, of course, after this process, it releases water into the atmosphere and it releases oxygen. We breathe in the oxygen, the water forms clouds and it rains, we drink the water, the plants drink the water, it makes more plants for us to eat. It's just a beautiful self-sustaining system. And here is the balanced chemical equation for photosynthesis, which is the process that plants use to make food. I know you already know this, I'm just reminding you. Take 6 molecules of carbon dioxide plus 12 molecules of water. You add energy from the sun. You end up with 1 molecule of glucose sugar, 6 molecules of oxygen, and 6 molecules of water. So after today's lesson, you will be able to take an unbalanced chemical equation and you'll be able to balance it. You have to make sure it makes sense. And you'll be able to, after a little practice, you can read a word problem or do this in a laboratory without having the equation already given to you. And why should you care about this? Well, there happens to be some high-paying jobs that depend on the use of chemical equations. Some of these jobs are used for helping people, making the world a better place. Doctors, pharmacists, medical researchers, chemistry professors, environmental chemists. They all depend on these skills that you're going to learn in this class. And what we're going to learn today is important to learn everything else that you have to do in this class. And, you can make a lot of money doing this. So, we're going to do a little review of molecular formulas. I know we did this last week, but it might be nice to have a little reminder. So, the molecular formula identifies all constituent elements in a molecule or compound. The number of atoms of a particular element in a molecule are represented as subscripts by the chemical symbol. The number of molecules is represented using a coefficient in front of the formula. So, in each molecule of glucose sugar, there is 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. And in this case, we have 3 total molecules of glucose. Alright, so say you have to find the total number of atoms in, more than one molecule of something. So say that is glucose, as in this situation. You have 3 molecules of glucose, and you want to know how many carbon atoms are present. You multiply the coefficient of the molecule by the subscript of the particular atom. So, there is a total of 3 times 6, 18 carbon atoms in 3 molecules of glucose. There is a total of 3 times 12 hydrogen atoms in 3 molecules of glucose. That gives you 36 hydrogen atoms. And you do the same thing with oxygen. 3 molecules of glucose times 6 oxygen atoms gives you 18 atoms of oxygen in 3 molecules of glucose. So now we get to the important part, the part that's not reviewed, the chemical equations. And here's an example down here. A chemical equation consists of 2 sides separated by an arrow. The left side is the reactants. This is what you start out with. Now, at some point, there's going to be something called the activation energy. And these atoms on the left side are going to recombine. And this is what you get on the right side, the products. There's going to be some bonds broken, some bonds reformed, but it goes from this to this. And all the matter has to be conserved. There has to be an equal number of each particular type of atom on the left side as there is on the right side. And that's what balancing them is doing. chemical equation. In this case, N2, which is molecular nitrogen, plus H2, which is molecular hydrogen, turns into NH3, which is ammonia. It's a gas. And does this look balanced to you, Deborah? You know it's not. I already said it wasn't.
Yeah.
I'm just making sure you're paying attention. Okay, so we're going to start by balancing one of the elements. Okay, so we have 2 nitrogens and 2 hydrogens on the left side. On the right side, we have 1 nitrogen and 3 hydrogens. So, it's not balanced. We have to start by balancing one of the elements. So, since we have less nitrogen on the right, we're going to start by putting a coefficient of 2. Now we have 2 nitrogens on both sides. But now we have 6 hydrogens on the right side and only 2 on the left. So I'm going to put a coefficient of 3 in front of the hydrogen on the left. So now we have 2 nitrogens on the left. We have 6 hydrogens on the right. 3 times 2 equals 6. 2 and 6. And we have 2 nitrogens on the right and 6 hydrogens on the right. 2 times 3. So that looks balanced to me. Does that look balanced to everybody else here? All right. So now we'll do an example problem. Hopefully you can read my handwriting. We have silicon dioxide, represented by SiO2, plus carbon, turns into silicon and carbon monoxide. Okay. Does this look balanced, Mr. Mosley?
No, it doesn't.
Okay. Is there anything I could do to fix this?
Well, the oxygen, there's 2 oxygen molecules in the reactant, but not in the product.
Oh, that's right. There's only 1 oxygen on the right, isn't there?
Yeah.
Okay. So if I put a coefficient of 2, now we have 2 oxygens in the reactant and 2 oxygens in the products. But that messes me up a little, because now I have 2 carbons in the products and only 1 carbon in the reactants. So I guess if I put a 2 here, then that evens it out. Okay. So for Si on the left, I have 1. For oxygen on the left, on the reactant side, I have 2. And for carbon on the reactant side, I have 2. So now I'm going to go over to this side, to the product. For Si, I have 1. For oxygen, I have 2. And for carbon, I have 2. Hey, that looks balanced to me. Okay. I have another example problem. Would anybody like to come up here and volunteer to work the problem? Or is Mr. Mosley going to have to do the whole thing himself? No volunteers? Ms. Smith, would you like to volunteer?
Okay.
Oh, thank you. You're so kind. Okay. So now we have tin dioxide, which is SnO2, plus molecular hydrogen, which is H2, turns into tin. Give a smaller arrow so there's room to write coefficient if you need. Plus 2 molecules of water, H2O. Okay. Now, let's see if this thing is balanced. So, how many tin, which is Sn, do we have on both sides? Is that balanced?
Yes, there's 1 on each side.
Okay. What about oxygen?
No, wait, yes, there is.
2 on each side?
There's 2, and then this is a coefficient, and that means the oxygen. The product is 2.
Okay. What about the hydrogen?
Hydrogen has 4 here because you multiply, right?
Yes.
And
Very good.
then there's only 2 on this side, so
you
but,
fix that?
it should be there.
Okay. So, we've got 110 on both sides. We've got 2 oxygens on both sides and 4 hydrogens on both sides. That looks balanced to me. Anybody else see a problem with that? Or does that look good? Okay, thank you, Ms. Smith. Thank you. All right. Well, I've got some packets for you guys. It's got a couple of handouts. It goes through all the components of a molecular formula and reminds you how to, find a specific number of a type of atoms in more than one molecule. Also, in the handout, or in the packet, there's a handout with the steps of balancing a chemical equation. I also have a worksheet that's due at the end of the period. And I have some homework that's due tomorrow. Okay. Does everybody have pencils? Anybody need something to write with?
I need to work with.
Okay. Everybody always forgets their writing utensils after spring break. So just go ahead and start working. If you have any questions, I'll come help you out. Get off to a quick start now. Everything going okay, Mr. Mosley?
Oh, yeah.
Okay. All good? Everything going okay, Deborah? Okay. Okay. Uh-oh. Well, you have 4 oxygens in the product, and you only have 2 here. So I can go over You get set, Deborah? Okay, okay. No, that is right. That is right. Yeah, that's correct. That's correct. Excellent, excellent. Okay. So I know you're not finished yet, but you all appear to have caught on very well. Appear to have caught on very well, very well. You seem to be ready to do your homework on your own, and I think you're ready for tomorrow's lesson. We're going to go into some word problems. We're going to go into some conversion, and I think you're doing okay. Anybody have any questions? No questions? Okay. Well, the homework is due tomorrow at the beginning of the period. And I'll just let you work on this for the rest of the class period. If you have any questions, I'll be up here at my desk.